to everyone. Today we are going to see about the unit number 4, losses and dispersion in optical fibers. Signal degradation in optical fiber, and basically we are having two type of degradation mechanism. One is an attenuation and one more is an dispersion. Both are the important characteristics of an optical fiber to finding the operating wavelength. These are all the two type of error we can occur after receiving the optical signal in the receiver side. Next, we are going to see about the attenuation. This is the most important characteristics of the fiber optical cable is the power loss in the fiber. The power loss is called as an attenuation, is also known as power loss or a signal loss. We can measure the attenuation in terms of decibel 10 log 10 pi divided by p naught. We know that what is in pi and what is in p naught. Pi is an input optical power or a transmitted optical power, and P naught is an received optical power or output power. Here we have to measure the in terms of attenuation in terms of dB. We can measure alpha dB into L because we are going to find out the attenuation per unit length. So we have to mentioning the L. L is nothing but an signal attenuation and L is nothing but an length of the fiber. And the basic mechanism of attenuation, one is an absorption, scattering, and third one is an radiative losses of the optical energy. Absorption is related to the fiber material and scattering are due to the fiber material with a structural imperfection in the optical waveguide, and the radiative losses occurs whenever an optical fiber undergoes a bend or a macroscopic or a microscopic of finite radius of curvature. First, initially we are going to see about the absorption losses. Absorption loss is related to the material composition and fabrication process of an fiber. Absorption may be caused by three different mechanisms. One is an absorption by atomic defect in the glass composition. Second one is an extrinsic absorption by impurity atom in the glass material. Third one, intrinsic absorption by an constituent atoms of the fiber material. And second one, classification of scattering losses. Scattering is nothing but an light split up in the receiver side. Here basically two type of scattering. One is a linear scattering and non-linear scattering. Again, linear scattering classified into two types, Rayleigh scattering and Mie scattering. Similarly, non-linear scattering is also divided into two types. One is an stimulated Bernoulli scattering and stimulated Raman scattering. We know that the linear, what does mean that linear? Here, in case of linear scattering, optical power is transferred from the one mode to the another mode, but there is no change in the frequency on the scattering. Here, mode is only different, but there is no change in the frequency of an signal. Here, two type of linear scattering, Rayleigh scattering and Mie scattering. First of all, we are going to see about the Rayleigh scattering. Rayleigh scattering is nothing but an how we can get it from that real time application. We can get the light from the sun. It is scattered in the atmospheric region, given in the sky or in the blue color. This type of scattering takes place in all the type of directions. Rayleigh scattering produces an attenuation in the light rays, and this type of attenuation is proportional to the 1 by lambda power 4. We know that lambda is an optical wavelength. If we transmit the data through an optical fiber cable at a higher wavelength, scattering is minimized. From that point, we can go through the we can take the wavelength of an input signal in maybe it is in higher wavelength. Automatically this type of scattering we can eliminate. Next, my scattering. This type of scattering caused by hologenetic, which is comparable in the size with this guided the wavelength is called as an my scattering. This is an only type of an linear scattering which always in forwarded direction. Factors responsible for an my scattering is given by cylindrical structure of cable is not perfect, imperfection of a core and cladding interface, and core and cladding in refractive index is not uniform throughout the fiber. There are fluctuations in a core diameter due to some bubble or a strain in the fiber. Next one, my scattering results significant attenuation depends on the fiber material, size, design and manufacturing process. It may be reduced by the following steps. One is an removing imperfections during glass manufacturing process, controlling the coating of an fiber, increase refractive index difference between core and cladding. Next type of scattering is a nonlinear. Here, from the title itself, we can understand the scattering should be in a nonlinear. When the optical power isn't transferred from one mode to another mode or a same mode with a different frequency, this is a main important point. The different frequency, this is an different frequency of signal we have means automatically the type of scattering is nonlinear. It maybe takes place in terms of forward and backward direction. It produces an optical gain, but there is a shift in frequency. This shift in frequency results loss of attenuation and creates attenuation. Nonlinear scattering is also divided into two types. One is an stimulated Brillouin and stimulated Raman. Thank you, one and all. Next class we can see the continuation part. Thank you.